Hi everybody, we are PBFluids. I'm Ling and my teammate is Wu. I'm going to briefly introduce the idea of our tool and how we'll show the output of our tool. Here's a two example output for our tool. So talking about the goal and objective, all you need for our tool is just you have the Maya installed in your computer. Since this is a Maya C++ plugin, so that's definitely what you need. And the functionality of this tool mainly contains two parts. The first part is that you can set the attribute for the position-based fluid simulation and create the simulation by just pressing the generate button. And the second part is that you can select an arbitrary mesh and you can either set it as the container of the fluid simulation or you can decompose it as the fluid initial status. For the feature, one thing is that it requires no learning curve. You can just simple and intuitive setup with the shape, density, and the number of particle parameter with our UI. And another thing is that, as I mentioned before, so it's a one button generate and a one button export. That means you can just click the generate button to generate the simulation, and you can click the export button to export the simulation you just generate as a format of video.
Now I will briefly introduce our technical approach. We adapted from the paper Position-Based Fluids by Miles and Matthias from NVIDIA. It uses a position-based dynamics, which is a fast and stable simulation method. And particularly, position-based dynamics with fluids introduces density as its sole constraint. In addition to the original paper, we also added several features that help us better integrate with Maya, including mesh decomposition, where we used a third-party library to decompose an initial mesh into some particles. And then there's the container collision, which basically decomposes a user-defined container and then collides the particles with these container triangles. Here are some clips of our tool. We start with a block of fluid and a fluid container. And we select the block of fluid to be the initial fluid and the container to be the fluid container. And then we click generate. It will produce this is the first frame, which is the initial mesh decomposed into a block of fluids. And then as we move the time along, we can see that the particles drop into the container. And we can modify the values in the Maya attribute editor. Now I'll demonstrate the real usage of our PBFluids node. In this scene setup, we have a container, which is a user-defined terrain. And we have two blocks of cylinders that we'll use to mark our fluids. So to launch our tool, we'll just click on PBFluids. This was loaded at the scene startup. And so we can see some sliders that we can change, some particle properties, simulation settings, and boundary settings. So let's change this to 6 because our terrain is more like 6 by 6. And now we have the optional parameters of custom meshes. So we'll select the fluid original model and set it to be initial fluid. And the terrain, we'll just set it to be container. And then we just create the PBFluid. And now you can see the animation is loading. It's basically generating 240 frames, and it's pretty quick. So you can see that in this default setting, because our time step is pretty small, the animation is pretty, I would say, volatile. It's fluctuating a lot. So what we can do to make it smoother is to just increase the delta t to be, say, 100. And now it will generate a new animation. And when it finishes, which is pretty fast, we can see that the animation is a lot smoother. And we can actually see that because of these values, which are like low values in the height map, the particles actually flow like a river. They flow along the valleys. And the last step that you can do is to export the animation. This uses Maya's built-in playbast. And then you have the animation stored over here, which you can play. Finally, here's our Git repo containing our source code and all of our results. By creating the PBFluids tool, we hope to help artists, designers, and students create fast and stable fluid simulation that can interact with Maya objects that they already have in the scene. Thank you.